More trigonometric graphs. The other trig functions besides sine and cosine also have periodic properties. The period of the functions tangent and cotangent is pi units each. So the tangent of x plus pi is equal to the tangent of x, and the cotangent of x plus pi equals the cotangent of x. Cosecant and secant each have a period of 2 pi, which is not too surprising since cosecant and secant are the reciprocals of the sine and cosine functions, which also have a period of 2 pi units. The basic graphs for tangent, cotangent, cosecant, and secant can be seen here. I am going to approach this as more of a review since most of you taking pre-calculus have probably seen these graphs before. But basically, we are just graphing y as a function of tangent of x, where x is the angle that we're taking the tangent of. And the same is true for the other functions here. So what I want you to notice is that they all have asymptotic behavior. So tangent has asymptotes at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, etc. And I'll jump down to secant and observe that secant has the same asymptotes that tangent has. So these two graphs have the same asymptotes. And then cotangent and cosecant have asymptotes at x equals 0, x equals pi, x equals negative pi, etc. Now there is a reason for this. Keep in mind that tangent of x is equal to sine of x divided by cosine of x, and secant of x is equal to 1 divided by cosine of x. So notice that anywhere that cosine of x is equal to 0 is where you're going to have an asymptote. So basically, cosine of x cannot be 0. And if you remember, the cosine graph looks something like this. And you can see that cosine is 0 at pi over 2, 3 pi over 2, etc. And that's precisely why we have these asymptotes at those values. Now, of course, for cotangent and cosecant, we can define them similarly. So for cotangent, it's cosine over sine, and for cosecant, it's 1 over sine. And we're going to have asymptotes wherever sine is equal to 0. So it's the same argument there. I think what students really need to do here is know how to graph the basic period of each of these graphs, especially tangent and cotangent. So if you're trying to memorize the tangent graph, you're not necessarily memorizing the whole thing here. You just need to know how to graph this first section and how to find its asymptotes. And then, of course, after that, the graph just repeats itself over and over again. For cotangent, the first so-called period is this section of the graph. Now, notice that the shapes of these graphs are the same, but swapped, right? So this is an increasing function. This is a decreasing function. And then also, of course, the asymptotes are a little bit different. For cosecant and secant, the best way to graph these is to actually graph their reciprocal functions. So let's keep in mind that cosecant is equal to 1 divided by sine of x. So if I impose the sine graph on here, what I want you to see is that the cosecant graph basically has an asymptote anywhere sine is equal to 0, right? And then it's a reciprocal. So wherever sine is getting smaller and smaller, cosecant is going to be getting bigger and bigger. So here sine is getting smaller, the y value is getting smaller, cosecant is getting bigger. And the same thing happens here, but in the negative direction. And of course, for secant, which is equal to 1 divided by cosine, the easiest way to graph this, of course, is to sketch the graph of cosine. And then you'll see that its behavior, right, so the behavior of this graph here in relation to the cosine graph is exactly the same as the behavior of the cosecant function in relation to the sine graph. So if we want to graph 2 tangent of x or negative tangent of x, this is all similar stuff here. So we take the tangent function, which is this blue graph here. 2 times tangent of x is just going to make the graph taller. So it does not affect its asymptotes. It does not affect its direction in terms of how it's sloping upward here, but it is going to make it a little bit taller. And so you can see this red graph looks very similar to the blue graph, but every y value is just twice as tall. Negative tangent of x is just going to take your standard tangent function and reverse it, flip it over the x-axis. And so this red graph here, that's the graph of negative tangent of x. All the asymptotes are still the same. So in graphing tangent and cotangent curves in general, if you have y equals a tangent of kx or a cotangent of kx, there is no amplitude for tangent and cotangent. So the a doesn't affect amplitude because there is none, but the a can affect the shape, right? So it can make it taller or it can make it shorter, or if a is negative, it can reflect it across the x-axis. But the primary thing is the k value. If you have a k multiplied to x, then the period of these graphs is going to be the normal period, which is pi, divided by that number k. So for example, if we have y equals tangent of 2x, the period's going to be changed there. The period will be pi divided by the number in front of x, which in this case is equal to 2. And so if the period is pi over 2, that means that it's going to go through one complete cycle from negative pi over 4 to positive pi over 4, because the distance between negative pi over 4 and positive pi over 4 is pi over 2 units. Now, there is another way to figure this out that I actually prefer. So what I do here is I'll remember that for y equals tangent of x, we know that the first period is going to be in between negative pi over 2 and positive pi over 2. So if I have y equals tangent of 2x, I'm just going to replace the x here with 2x. So I'm going to replace the x here with 2x as well. So 2x will have to be in between pi over 2 and negative pi over 2. And then if I just divide by 2 here, you see this is how we can determine where those asymptotes are going to be now. And so now the first period of tangent, in this case, is going to occur between negative pi over 4 and positive pi over 4, which is exactly what you see on here. Now, the tangent graph itself looks pretty normal, and then after that, of course, it just repeats itself over and over again. For the other one here, we have y equals 2 times the tangent of x minus pi over 4. So again, the 2 is just going to make the period pi over 2, just like it did in this graph here. But the negative pi over 4 is going to shift it to the right pi over 4 units. So instead of going through the origin here, it's going to go through pi over 4, 0. So again, what I like to do here to get the graph is just take whatever you're taking the tangent of. So in this case, it's 2 times x minus pi over 4. And we're going to say that has to be between pi over 2 and negative pi over 2, because those are the normal asymptotes for tangent. Dividing both sides by 2 is going to give us negative pi over 4 less than x minus pi over 4 less than pi over 4. And then adding pi over 4 to everything gives us this. And so we know that the first period is going to be between 0 and pi over 2, which is exactly what you can see here. Here's x equals 0, here's x equals pi over 2, and here is the graph of your tangent function. And then after that, of course, it just repeats itself over and over again. When graphing cotangent, it works the same way. So in this case, we have y equals 2 times the cotangent of 3x minus pi over 4. So the 2 is just going to make the graph a little bit taller. So we don't have to worry too much about the 2 here. But this, of course, is going to shift the asymptotes, and it's also going to change the period. So if we have y equals cotangent of x, we know that normally the first period would be between 0 and pi. So if I have y equals the cotangent of 3x minus pi over 4, Now we know that 3x minus pi over 4 must be in between 0 and pi. And then from there, if I add pi over 4 to all three of these, we get this. And then if we divide everything by 3, we're going to have pi over 12 less than x less than 5 pi over 12. And those are where the asymptotes are going to be. So you can see on the graph here, we have pi over 12. That's where our asymptote is. And then 5 pi over 12. That's our second asymptote. And then we have to know for cotangent, the regular cotangent graph, looks like this. And so this is going to be sloped in the same direction, but it is twice as tall. Okay, so it's going to come down like this. And then, of course, repeat itself. For the graphs of cosecant and secant, so specifically a times cosecant of kx and a times secant of kx, the period will be 2 pi divided by k, assuming that k is a positive number. But the best way to graph the cosecant and secant graphs is to first graph the corresponding sine or cosine graphs. Let's take a look at an example. So if I want to graph y equals 1/2 times cosecant of 2x, you can see the graph there, but how do I get that particular graph? Well, what I'm going to graph is y equals 1/2 times the sine of 2x, because the reciprocal of cosecant of 2x is sine of 2x. Now, 1/2 times the sine of 2x, that's going to be a graph that has a period of 2 pi divided by 2, which is equal to pi, and the amplitude would be equal to 1. And so to graph that, it's going to go through the origin here. At pi units, it's going to finish its first period. At pi over 2, it crosses. And then at pi over 4 here, it's going to hit 1. And at 3 pi over 4, it's going to hit -1. And so here is the graph of 1/2 sine of 2x. Now, once you have that, you can see that the asymptotes for cosecant occur everywhere that sine hits the x-axis. So we have these asymptotes here. And then these U-shaped sections of the graph always just come off the top of the sine graph or the bottom of the sine graph. So that's the easiest way to graph these things. The same thing is true for the second one here. So if I wanted to graph 1/2 cosecant of 2x plus pi over 2, I would first graph 1/2 sine of 2x plus pi over 2. And then that graph, of course, would look like this. I won't go through the details here, but once you graph that sine graph, once again, everywhere it hits 0, it's going to have an asymptote. And everywhere you have a high point, you'll have a U-shaped section going up. And everywhere it hits its low point, you will have a U-shaped section going down. So the easiest way to graph cosecant or secant functions is to first graph either sine or cosine, right? The reciprocal of the function. So we'll end here with a secant example. If I want to graph y equals 3 times the secant of 1/2 x, I'm going to graph first 3 times the cosine of 1/2 x. That has an amplitude of 3, a period of 2 pi divided by 1/2, which is equal to 4 pi. And now cosine normally would start high at 3, and then at 4 pi, it would end at that same point. At 2 pi, it would be at its low point, and then it would cross the x-axis in between those. And so here is the graph of the cosine curve. And then just like with cosecant, from there, you can graph the secant function by simply making these sort of U-shaped curves and putting the asymptotes in everywhere the graph crossed the x-axis. And that concludes this video lesson.